Chapter 4, Section 3, Graphs of the Tangent and Cotangent Functions. In this section, what we're going to do is we're going to learn how to graph the tangent and cotangent functions just like we did in the previous chapters for the sine and cosine functions. So, first thing you need to understand is the tangent and cotangent functions are graphed totally different than the sine and the cosine functions. So the second thing is to determine the asymptotes by setting the arguments of the functions equal to the natural asymptotes. And this is kind of like what we were doing earlier as far as doing a compound inequality, and I'll show you how to do that. So for tangent, here's your basic function for tangent. And you see that we still have the A, which is the amplitude. We still have the B, which is going to be the coefficient of your angle. And again, A is going to be the coefficient of your trig function. Now, one thing that you need to understand is that in a tangent and cotangent function, and if you look in your book, you can either look on the inside back cover of your book, or you can look on pages 169 and 170 and see those. So the main thing that I want you to notice here is that we do have asymptotes with the tangent and cotangent functions, and basically what that means is this graph cannot cross over the tangent or the asymptotes. So it's undefined at those asymptotes. So our basic asymptote for a basic tangent curve is going to be at negative pi over 2 and pi over 2. So the basic curve, no shifts or anything of tangent, is negative pi over 2 and pi over 2. So for cotangent, you have your A, which is going to be the coefficient in front of your trig function. You have B, which is going to be the coefficient of your angle, and now cotangent is its natural range is going to be from or domain is going to be from 0 to pi. So again, for tangent, the natural period is the natural domain is going to be from negative pi over 2 to pi over 2, and for cotangent, the domain is going to be from 0 to pi. Now, that means that this is going to have somewhat of a period of pi. Each one of these has a period of pi, whereas sine and cosine had a period of 2 pi. So what we're going to do after we figure out what these asymptotes are going to be, remember, determine the asymptotes by setting the argument of the function, that's going to be your angle, equal to the natural asymptote. So the natural asymptote for tangent is going to be negative pi over 2 and pi over 2. So you're going to set your argument equal to each one of these asymptotes. And same thing for cotangent, you're going to set your argument equal to each one of these. Once you know what your asymptotes are going to be, draw the asymptotes. And remember, an asymptote is just an imaginary vertical line. Find 3 other points inside the asymptotes by first locating the midpoint and then bisecting the 2 leftovers. I'm going to do it a little bit differently, but you can do this this way if you want to. Then you're going to set up a table of values. That's going to be your t-chart, and substitute them into the equations to determine the y value, and then plot the points and draw the curves. And again, this is that website that you can go to if you want to see what the curve looks like and play around with that. Okay, so what we're going to do is we're going to graph y equals tangent 3x. And this is the basic tangent curve, but it is a triple angle. So since it is a triple angle, then it is going to be more narrow. So notice that our asymptotes are going to be narrower. Alright, so what we need to understand here is that we have a period of pi divided by b, which is going to be 3. So our period is going to be pi over 3. And also we need to understand that we have to have our asymptotes. So for our asymptote, remember, we're going to go from negative pi over 2, and then we're going to have our argument to pi over 2. So basically we're going to divide each one of these by 3. And so when we do that, we get an asymptote at negative pi over 6, and we get an asymptote at pi over 6. So basically our graph has to be between those two things, or those two marks. So we have an asymptote at negative pi over 6 and an asymptote at pi over 6. So what we need to do is we need to figure out how to get our increments, because remember, this is going to be x and this is going to be tangent of 3x. So we have an asymptote at negative pi over 6. We've already figured that out. This is going to be an asymptote, which means this is undefined, and it is going to make an asymptote. Alright, so to get to our next increment, what we're going to do is we're going to take this pi over 3, our period of pi over 3, and we're going to multiply by 1/4. And we will get pi over 12. So what we're going to do is we're going to take this negative pi over 6, and we're going to add pi over 12 to it. So when we add pi over 12, again, use your calculator, negative 1/6 plus 1/12 is going to give you negative pi over 12. And then to get to the next one, what we're going to do, I'm going to run out of boxes again, but that's okay. What we're going to do is we're going to take negative pi over 12 and add pi over 12, and that's going to get us to 0. And then for the next one, we'll have 0 plus pi over 12, which of course is going to be pi over 12. Alright, so now what we're going to do, and then our last one of course is pi over 6, which is going to be that asymptote. So now what we're going to do is we're going to take this negative pi over 12 and plug it in for x. So 3 times negative pi over 12, that's what we're doing, 3 times negative pi over 12. And that's going to be negative pi over 4. Well, we have to ask ourselves, what is tangent of negative pi over 4? Tangent of negative pi over 4, again, have your unit circle available. Negative pi over 4 is going to be negative 45 degrees, so we're using the 45-90 reference angle. And so that's going to be at, so that's going to be negative 1. So again, we're using that 45-90 triangle, and because of the negative pi over 4, and so basically it's going to be 1 over 1, but it's negative, and we know that it's in quadrant 4, and tangent is negative in quadrant 4, so that's going to be a negative 1. Alright, so for 0, same thing. We're going to take the 0 and we're going to plug it in here. 3 times 0 is going to be 0. And then tangent of 0 is going to be 0. And then we have pi over 12, so if we plug pi over 12 in here for x, we have 3 times pi over 12, which is going to give us pi over 4. Pi over 4 is 45 degrees. Tangent of 45 degrees is going to be a positive 1. So we have 3 ordered pairs here, and so we have negative pi over 12 is going to be negative 1. We have 0, 0. And we have pi over 12 and go to positive 1. So our curve is going to come in like this and look like that. And of course our asymptotes means that it's going to go on forever and ever without crossing the asymptote, of course. Alright, so let's try again. This is cotangent, and remember, for cotangent, we are naturally going to go from 0 to pi. From 0 to pi. So here we have an amplitude of 2, and we have a period of pi, the period's pi, divided by b. Well, this can be written as 1/2 x. So we're going to divide by 1/2, and that's going to equal to 2 pi. And then, of course, to figure out what increment we're going to add to each one, we're going to fourth it again, and so 2 pi times a fourth is going to be pi over 2. So we're going to add pi over 2 each time. Alright, so now we have to do our natural to figure out where our asymptotes are. We're going to have 0 less than x over 2 less than, I don't know why I put equal to, because it can't be. Oh, I did it again. It cannot be equal to because it's an asymptote. So you're going to have 0 less than x over 2 less than pi. And so what we're going to do is we're going to multiply everything by 2, and so we're going to get 0 less than x less than 2 pi. Alright, so we know that we have an asymptote at 0, so we have an asymptote here at 0, and we also know that we have an asymptote at 2 pi. That's what this tells us. This tells our asymptotes. Alright, and so now if we let this be x and let this be f of x, or y in this case, we know that we have an asymptote of 0. So what we're going to do is we're going to take 0 and we're going to add pi over 2 to it and get pi over 2. So that's going to be our first ordered pair. And then we'll take pi over 2 and add another pi over 2, and that's going to give us pi. And then we're going to take pi and add another pi over 2, and that's going to give us 3 pi over 2. And then, of course, if we add another pi over 2, that's going to get us to 2 pi. Okay, so now what we're going to do is we're going to take pi over 2 and we're going to plug it into our function for x. And so if on this one, let's write it like this. Let's do 1/2 times x, which is going to be pi over 2. And that's easier to see, so we're going to get pi over 4. Okay, so again, we have cotangent of pi over 4, cotangent of pi over 4, cotangent of 45 degrees. So we're still working off that 45, 45, 90. So that's going to be 1, and then 2 times 1 is going to be 2. Alright, and so we have pi, and so if we do half of pi, that's going to give us pi over 2. And so if we do cotangent of pi over 2, cotangent of pi over 2 is going to give us 0, and 0 times anything, of course, is 0. And if we do 3 pi over 2, so we do 1/2 times 3 pi over 2, that's going to give us 3 pi over 4. 3 pi over 4, again, that's going to be the 45, 45, 90. And so that's going to give us -1. So cotangent of -1, of course, and times 2 is going to give us -2. Alright, so we have our ordered pairs. We have pi over 2 and 2. So pi over 2 takes us to 2. Pi is going to be 0, and 3 pi over 2 is going to take us to -2. So notice that when we do this one, the cotangent function is kind of backwards, mirror image, I guess. Not mirror image, but reflected from the tangent curve. So we're going this way, but this one has an amplitude of 2, and it's a half angle, so it is stretched. Alright, so let's look at this one. We have tangent of 2x minus 3/4. Tangent of 2x minus 3/4. And on this one, we have an amplitude of 1, because there is a 1 here. And then our period, again, remember, natural period for tangent is pi. but then we're going to divide by b, which in our case is 2, so we have pi over 2. And then we are going to multiply it by a fourth, and we're going to get pi over 8. And that's what we're going to add each time for our increments. And then to figure out our asymptotes, now remember tangent is going to go from negative pi over 2, and then we have our argument of 2x minus 3 pi over 4 this time because we have a shift, and then we have less than pi over 2. So remember we do have a shift here. Okay, so we're going to add 3 pi over 4. We're shifting it to the right, 3 pi over 4, so we're going to add 3 pi over 4 to every side. And so when we do that, we're going to get pi over 4 here. And then we're going to get 2x, and then we're going to get 5 pi over 4 here. And then we're going to have to divide everything by 2. And when we divide everything by 2, we're going to get pi over 8 is less than x is less than 5 pi over 8. And so that's our asymptote. So we have an asymptote here, and we have an asymptote here. Alright, so for our first one, again, this is going to be x, and this is going to be f of x or y, whichever one is your total function. Alright, so for the first one, we know that we have an asymptote at pi over 8. So to get our first increment, we're going to take pi over 8, and we're going to add pi over 8. Okay, we're going to add pi over 8. And when we do that, we're going to get pi over 4. And then we're going to take pi over 4 and add pi over 8 to it again to get our next increment, and we're going to get 3 pi over 8. Again, that's calculator work. You're going to take pi over 4, 1/4, and you're going to add 1/8 to it. And when you do that, you get 3 pi over 8. And then you're going to take 3 pi over 8, and you're going to add pi over 8 again. And when you do that, you're going to get pi over 2. And if you added pi over 8 again, that would get you to 5 pi over 8. Alright, so now what we're going to do is we're going to take this pi over 4 and we're going to plug it in to this function. So basically we're doing tangent of 2 times pi over 4 minus 3 pi over 4. And so you have tangent of pi over 2 minus 3 pi over 4, and so that's going to get you tangent of negative pi over 4, and tangent of negative pi over 4 is going to get you negative 1, because again we are on the 45/45/90s. Okay, and so if you do 3 pi over 8, then you're going to get 0. And if you do pi over 2, you're going to get 1. Alright, so pi over 4 takes us to negative 1. That's down here. 3 pi over 8 takes us to 0, and pi over 2 is going to take us to 1. So here is our tangent curve. And it looks like that. Alright, so let's look at this last one. And if we look at this last one, we'll notice that for cotangent, your period is pi, but b is going to be 1, so it's still going to be pi. And then if we fourth that, we're going to get pi over 4. So this is what our increments is going to go up by. And then to find our asymptotes, we're going to have, for cotangent, we're going to have 0 less than x plus pi over 2, or 1/2 pi, less than pi. So if we minus pi over 2 from both sides, like that, we're going to get negative pi over 2 less than x less than pi over 2. Alright, so there's our asymptotes. So we're going to go from negative pi over 2 to pi over 2. And so we need to get our increments. So we're going to have x, and we'll have f of x, or in this case, y. Alright, so if we go from our first asymptote, negative pi over 2, here, if we go from our starting point, negative pi over 2, and we add pi over 4, that's going to get us to negative pi over 4, and again, that's just pure calculator work. And then negative pi over 4 plus pi over 4 is going to get us to 0. And then, of course, 0 plus pi over 4 is going to get us to pi over 4. Now, if we do some math here, we're going to do, I'll just help you do the math again. 3 plus cotangent of x, which is going to be negative pi over 4 plus pi over 2. So we're going to have 3 plus cotangent of pi over 4. And again, that's the 45, 45, 90. So we're going to have 3 plus cotangent of pi over 4 is going to be 1. And so we'll get 4. And then we'll do that exact same math for 0. And when we do that, we're going to get pi over 2. So 3 plus pi over 2 is going to, or 3 plus 0 is going to be 3. So when we plug 0 in here, we're going to get cotangent of pi over 2. Cotangent of pi over 2 is going to be 0, and then 3 plus 0 is going to be 3. And when we plug pi over 4 in, pi over 4 plus pi over 2 is going to give me 3 pi over 4, and then cotangent of 3 pi over 4 is going to be negative 1, and so 3 plus negative 1 is going to be 2. So when we graph that, we're going to have negative pi over 4 is going to go up to 4, 0 is going to go to 3, and pi over 4 is going to go to 2. So we've taken our base cotangent function and we've shifted it up 3, but we've shifted it to the left pi over 2. So remember, normally our cotangent is going to go from 0 to pi, but we have shifted it to the left pi over 2. And so it's going to go like this. Alright, so what I'd like you to do is I'd like you to try these numbers. If you have any problem, bring them to class and they will be discussed.